Alright, today we are going to be solving multi-step inequalities, and our objective for today is to be able to solve linear inequalities involving more than one operation, and also to solve linear inequalities that involve the distributive property. So let's go ahead and get started on that. Alright, the first thing that we need to know is what these signs, what the inequality signs are. So right here we've got our four inequality signs. We've got the greater than, the greater than or equal to, because notice it's got the line underneath it, the less than, and the less than or equal to. So what I'd like for you to do now is go ahead and pause the video, because there are important words that mean greater than. So that would be is more than, is greater than, is larger than, and above. If you see those in a word problem, that means you're going to use the greater than sign. The greater than or equal to means minimum, at least, is not less than, or is no less than, and then not smaller than. These are very tricky, all of these, because many students will think because it says minimum or least that it means less than, but it's actually the opposite of that. It's the greater than or equal to. So definitely make sure that you write these down. You will see them on your quiz. And that word there is equal to. Okay, less than, of course, means is smaller than, is less than, below. Also, the other thing that I want to point out here is these are not flip-flop words. Whenever you see is less than, if you have something like x is less than 5, you write x, the less than sign, and then 5. This last sign here is the less than or equal to, and the words that mean that would be maximum, at most, no more than, no greater than. These are also very tricky to students because whenever they see maximum, they want to put the greater than or equal to or greater than sign. But remember, if it's maximum at most, that's going to be less than or equal to. So remember, if the maximum grade that you can get on your quiz is 100%, that means you can get 100 or lower. So that would be less than or equal to. The other thing that I wanted to point out over here is over on to the right side, this chart. If they ever tell you to graph x is equal to 3 or x is equal to any number, that just means to put a dot on the 3. If it says that x is greater than or equal to, that is going to be a closed circle. And notice that it is pointing to the right. And all of our greater numbers are to the right. So you're going to shade to the right. These signs are actually pointing to the direction that you need to go. So this right here is pointing to the right. So we shade to the right. This one right here is pointing to the left. So you shade to the left. And this has the equal sign underneath of it. So it's going to be a closed circle and shading to the left. Alright, notice the one below. This one does not have the line underneath it. This is just the greater than. So that's why this is an open circle. And it's greater than, so we shade to the right. And the last one here doesn't have the equal to, so it's an open circle. It's the less than, so we shade to the left. So those kind of gives a little bit insight of if it's a closed circle, open circle, and if you're going to shade left or to the right. So let's go ahead and get started on solving some of these inequalities here. Here is our example 1. And we're trying to get the h all by itself. So our steps are going to be the same steps whenever we're solving equations. We want to get that h all by itself. We have to get rid of that minus 26. So we add 26 to both sides. So a negative 26 and a positive 26, those are going to cancel out. We bring the h down, bring down the inequality sign, and 4 plus 26 gives us 30. So now we would graph it. So on your number line, you would put 30, 31 is to the right of it, to the left of it is 29. If you want to fill out your number line completely, you can. All I'm worried about is 3 numbers there. Now, because this doesn't have the equal, the line underneath it, this is going to get an open circle, and it's less than, it's pointing to the left, so we shade to the left. Also, anytime you are solving inequalities, you want to make sure that the variable is on the left. This is not the case where it's okay to keep the variable on the right. On inequalities, you want the variable on the left. Okay, example 2. Here we've got 3 different types of problems, but all, very similar. So looking at the very first one, all of our numbers are positive. Looking at the second one, just the coefficient, the number in front of the x, the negative 3/4, that's what's negative. And then looking at the third one, the 9 is negative, but the coefficient is positive. So let's look at the difference of these whenever we are solving them. So right here we need to get the x by itself. We see that the 3/4 is being multiplied, so we know the inverse of multiplication is division, so you're probably thinking, oh, we need to divide 3/4 on both sides. But then you remember, hey, we do not divide fractions. What do we do with fractions? And I hope you're saying that we multiply by the reciprocal. So the reciprocal, that is 4/3. So we multiply by 4/3 on both sides. So we know that whenever we multiply by the reciprocal, that's the inverse of those cancel out, and we're left with x is greater than, and then you take the 9, multiply it by the 4, divide by the 3, and that gives us 12. Or remember, you can also take the 9, divide by the 3, multiply by the 4. Still gives you that 12. So then we put 12 on our number line, 13 goes to the right, 11 goes to the left. This one is greater than or equal to, so it gets that closed circle. And we shade to the right because it's greater than or equal to. So now looking at the second one there, the negative 3/4, we're going to multiply by the reciprocal again, but the reciprocal this time is negative 4/3. We're going to multiply by negative 4/3 on both sides. Now, negative 4/3 times negative 3/4 still gives you that positive x. 9 times negative 4 divided by 3 gives us negative 12. Now whenever you're multiplying by a negative, you need to make sure that you flip that inequality sign. So instead of greater than or equal to, it becomes less than or equal to. And that's only when you multiply or divide by a negative. That right there, because that number is negative, that's why we flip the sign. Now tomorrow in class we'll go in greater detail of why we actually do that. So now we're going to graph it. We've got negative 12 there. Remember, to the right of negative 12 is negative 11, and to the left is negative 13. So remember, your negatives will go backwards. All right. This is a closed circle because it's less than or equal to, and then we shade to the left. Okay, now the third one right there, the positive 3/4 x is greater than or equal to negative 9. We are going to multiply by the reciprocal, which is 4/3. That gives us x is greater than or equal to negative 12. So notice here, because we are multiplying, this 4/3 is positive. The sign, the inequality sign, that the inequality sign greater than or equal to, it stays greater than or equal to. Okay, so it didn't get flipped there. So this -9 means nothing about flipping the inequality sign. So we're going to put our -12 down there. To the right is -11, to the left is -13. This gets a closed circle, and because it's greater than or equal to, we shade to the right. All right, example 3. Right, on this one, we're still going to need to distribute here. So that gives us 30x. 6 times -3 is a -18. This is less than or equal to 36x. So now, remember I said you want to move your variables to the left. Well, if I get rid of this 36x and move it over to the left side, then I won't have anything on the right side. So I am going to subtract 30x and actually move my variables over to the right. Bring down a -18, bring down the less than or equal to sign, and 36x minus 30x gives us 6x. And now I need to get the x by itself, so I divide both sides by 6. Notice we are dividing by a positive 6, so this inequality sign, it stays the same. It's still going to be less than or equal to. And then -18 divided by 6 gives me -3. But now remember, I said your variable always needs to go in the front, or over onto the left side. So I'm going to move the x over to the left side. The -3 goes over onto the right side. Now notice the inequality was pointing at the -3. It still needs to point to the -3. So make sure whenever you're moving your variable over to the left, if it was over on the right, this inequality sign flips over. And that's only when you get down to the variable at the end, okay, and you need to move it over there. All right, so now let's go ahead and graph this. We've got -3, to the right of -3 is -2, to the left is -4. This gets a closed circle and shading to the right. All right, example 4, this one's just getting a little bit more, with a little bit more steps here, but still we're going to follow the ones that are steps from solving equations. So we're going to distribute here. It gives us 2h plus 12 is greater than, distribute the -3. -3 times 3 gives us -9. -3 times -h is a positive 3h. Now I'm going to move the variables over to the left, so I'm going to subtract 3h. Those will cancel out. 2h minus 3h gives me -h or -1h. Plus 12 is greater than -9. Now get rid of that plus 12 by subtracting 12 on both sides. Those will cancel out, bring down a -h is greater than -9 and a -12. Those are same signs. We add, and we've got more negatives than we do positives, so that's -21. Now, with the negative in front of the h, we have to get rid of that negative. There are several ways that you can do this. You can divide by -1 on both sides, and whenever you do that, we are dividing by -1, so you need to flip the inequality sign, or you can just take the opposite of everything. The opposite of -h is h, the opposite of greater than is less than, and the opposite of -21 is 21. So make sure whenever you're getting rid of a negative sign in front of the variable, you flip that inequality sign. So now let's go ahead and graph it. We've got 21, 22 is to the right, 20 is to the left. This is going to get an open circle because it does not have the equal sign. And since it's less than, we are shading to the left. And there's your solution. All Alright, our last example for today. So, example 5, we're going to solve 37 is less than 7 minus 10w. So on this one, remember we want variables on one side. Actually, we want variables on the left and the constants on the right. But if I move the variables over to the left, well, you know what? It might be easier if you do that. Let's go ahead and get rid of that minus 10w by adding 10w on both sides. But notice over here that it's not a like term with the 37, so do not put it underneath the 37. So then you'll have 10w plus 37 is less than 7. So now that should look a little bit easier than what we had before. So now we're going to subtract 37 on both sides. Those will cancel out. We're left with 10w is less than 7 minus 37. We've got different signs, so we're going to subtract. We've got more negatives than we do positives, and that gives us negative 30. Divide by 10w. Notice that I am dividing by a positive number, so my inequality sign stays less than. So then over on our number line, we've got negative 3. Negative 2 is on the right, negative 4 is on the left. This gets an open circle, and it is less than. It is pointing to the left. We shade to the left. Alright, and that's it for our solvent inequalities. We will be doing a lot of practice of this in class. If you have any questions, please let me know.